Okay, hello. I got disconnected. Now am I audible?
Yes, ma'am.
Ma'am.
Okay, okay. Okay, so I was talking about the domestic water demand. So the water which you use for your residential buildings, okay, for your own purpose, like whether it may be your drinking purpose or cooking purpose. So all this, it is known as your domestic water demand, as the name suggests. Okay, so now there are some, you can say, some limits are given, not limits, basically some range is given. So basically, in suppose for water demand, for domestic water demand, so how much of water is actually needed for or provided for your domestic water demand. So as per your municipality, so that one, the range for your domestic water demand is basically your 200 LHD. Okay, so what is LHD? LHD is your liters per head per day. Okay, let me annotate it. You can see then. Okay, so here you can see this line. It is your for like minimum domestic consumption that is required for any city or for any town. Okay, so that is your 200 LHD. So what is LHD? LHD is liters per head per day. That means one person is needing how much of water, okay, how much liter of water per day. That is your LHD. Okay, so the minimum domestic consumption that is required for a city, okay, so that for domestic water demand is your, the minimum amount is your 200 liters per head per day. Okay, and also this 200, if it is a very economically weaker community, then this 200 LHD, it can be reduced to your 135 LHD. So you have to remember these two values. Okay, these two values you have to remember. For each and every water demand, there are some ranges. Okay, the ranges of water demand, so that one you have to remember. And this demand, this range, it is as per IS 1172 1993. Okay, as per IS 1172 1993. So these ranges are given. Okay, now the next is your industrial water demand. Okay, next is your, okay, just wait. Okay, so the next is your the industrial water demand. So from the name again, you can know that the industrial water demand, it is the water that is demanded by or that is used by the industries. Okay, so whether like it is existing or it is likely it is going to start. So basically, and one more thing, like whenever you are this you are designing a water supply scheme, so you have to know the water demand. Okay, not only for the present time, but also you have to know how much water is going to be demanded by the public in the next 10 years or in the next 20 years. You are not going to know only, you are not going to consider only for this year we are going to design a water supply scheme. Not like that. You have to consider for next 20 years, for next 10 years you have to consider, and then only you have to design the water supply scheme, because it is a very costly project and you cannot for you by year you cannot design every time. Okay, so that's why you have to consider the next 10 years or next 20 years. For the future you have to consider. Okay, so here basically for the industrial water demand, what is the per capita consumption? Per capita consumption, then this term per capita consumption is also same. That is your how much liter of water is required by a person per day. Okay, on a single day, how much of water is required by a person per day. Okay, so that is your per capita consumption. So here also for your per capita consumption also, you see the this for industrial needs, it is your 50 liters per person per day. So this value you have to remember. Okay, and now again, for the industries that are in the cities, so those are your, it can go up to 450 liters per person per day. Okay, it can go to 450 liters per person per day. And also the normal industrial requirement also, it can be, it is 50, but it can be, increased, it can be increased to your 450 liters per person per day. And the normal requirement, or normal whatever water is demanded by these industries, it is your 50 liters per person per day. Okay, so these two values you have to again remember for industrial water demand. So next is your institutional and commercial water demand. So what is institutional commercial water demand? Suppose you people are coming to our college, okay, you are attending this college, and you also need water in college, isn't it? So you use it for, whether it can be for your washroom, okay, so any purpose you are using for drinking water. So whatever water it is demanded by, for the restaurants also, you can say, for hospitals you can say, for this schools and colleges you can say, then it can be either the railway stations or airports. Okay, so these places are your commercial places or institutional places. So whatever water is required for any of these places, so it is known as your industrial, sorry, institutional and commercial water demand. Okay, so here, what is the what is the per capita consumption of the institutional water demand? So it is like, for the commercial establishment and institutions, the average per capita demand is your 20, okay, 20 liters per head per day. Okay, so this value you again remember. Then next is your for your that is your demand for public uses. So what is the demand, water demand for public uses? So this demand, it includes, like, like whether you are using the water which is demanded by these parks and all, for if you are gardening in public places, so whatever water is required for gardening, or you are using the water for in public fountains, or you are using the water for sprinkling the water on the roads. So all these things are your demand for public uses. Okay, so all this includes the water which is required for all these purposes is known as your demand for public uses. And what is the per capita consumption for your public uses? It is your 10 liters per head per day. Okay, it is your 10 liters per head per day for your public demand. Okay, now next is your fire demand. So what is fire demand? So this one, obviously, in a very in cities like where we are residing, where the population is very large, or where there are many industries, so obviously it is generous that there might be fires breaking out, isn't it? So what is done here is that in some places, these the firefighting squads, like there are these pumps and also these are already fixed in some places. So fire hydrants are there which are fitted in this, like in the water mains. So all these things are already present in some big cities. So the water which the per capita consumption which is required for your firefighting things is your 1 liter per head per day. Okay, so for firefighting purpose, since it is mandatory, it is required, it is very important, because otherwise the places would be destroyed if a fire is taking place. So immediately you need water, and you have to store water for that purpose while you are designing. So that is your the per capita consumption, it is given as your 1 liter per head per day. Okay, now whenever you are the per capita demand of this fire requirement of a city, it is generally if some population it is exceeding like 50,000 persons are in a city where the population is like it is more than 50,000. Okay, so it is more than 50,000. Then what is the kiloliter of water the required? There is one formula. Okay, what is the water required in kiloliter? It is your 100, okay, root over p. Okay, this formula. in a city or in a place or in a city or in a town where the population it is exceeding 50,000, so the water required is in kiloliter and it is given by a relation which is your 100 root over p, where what is this p? This p is the population in thousands. Okay, this p is the population in thousands. Later I will show you, when we will do some numericals, I will show you how to compute this p. Okay, so now this rate of water, this rate of fire demand, we are talking about fire demand now here. So this rate of fire demand, you know, it can be you know, like there are some different formulas by which you can find out how much of, you know, water is required for a fire demand. Okay, so there are different 5 or 3 4 types of formulas are there, you have to know all those. So number one formula is known as your Quichling's formula. Okay, number one is your Quichling's formula, and this formula it is like given by the formula 3182 root over p. As you can see in the screen, it is your 3 q is equal to 3182 root over p. So what is q here? Q is the, what is the amount of water is required in liters per minute. Okay, the unit will be in liters per minute. Okay, if in a numerical, if it is given in liters per minute, then you remember that it is not required to change the unit, since in the formula itself the q it is in liters per minute. Okay, so q is your what is the amount of water that is required in liters per minute, and p as usual it is your population in thousands. Okay, now second one is your Freeman formula. Okay, second one is your Freeman formula, which is given by the equation you can see here. Okay, you can see here the formula, it is your q is equal to 1136, okay, bracket p by 10 plus 10. Okay, this formula is known as your Freeman's formula. Okay, now here also q and p, they both are the same, like you have learned about the Quichling's formula. So q and p is same. Q is your amount of water that is required in your liters per minute, and P is in your thousands. Okay. The
What
next is
about ma'am 1136?
11366, the
What?
value. These are fixed value. This formula is already given in some IS, this Freeman. This Freeman is a person. He has given this formula already.
Oh,
Okay.
can you give some idea that 113 indicate what?
What 113 indicates what? It is a formula. What 113 is not indicating anything else. Only this q and this p are indicating. Q is your this required amount of water, and p is your population in thousands. 1136 and 10, all these things are already given by him. You cannot ask what is 113, what is 10. Understood?
Okay, okay.
Okay, so next is your National Board of Fire under writer's formula. So this is again another formula, and under this formula, okay, so there are, you know, certain things, like it is given that in a National Board of Fire in under writer's formula. So there it is already given that if for a, like if a city, it is a very congested city or it is a very high valued city, so where the, you know, the population it is like it is less than or it is equal to 2 lakhs. Okay, if the population in a very high valued city or a centrally congested city, it is like the population is less than or equal to 2 lakhs, so what will be the formula? So it is again already given, it is given by them, the National Board of Fire and the writers formula. It is given by them, it is recommended by the board that the formula is your this one, q is equal to 4637 root over p 1 minus 0.01 root over p. So this formula you are going to use only if it is mentioned that if the population it is less than or equal to 2 lakhs. Okay, if it is written that if the population is more than 2 lakhs in a high valued city, then you have to use like 54,600 liters. It is already mentioned, the value is already mentioned. Okay, it is no need to find out by using any formulas like you are using when the population is less than 2 lakhs. So if it is given in the numerical, suppose it is given if the population it is more than 2 lakhs, then you no need to find out by using any formula. You can directly put the rate of the water demand, fire demand is your 54,600 liters per minute. Okay, and if suppose an additional fire is breaking out, the first fire is breaking out, then the water demand it is, you can write it as your 54,600. By any chance, if some you have to use some extra additional water for suppose a second fire is breaking out, then you can add, 9,100, okay, 9,100 to 36,400 liters per minute. If any by chance any second fire is also break out in the nearest place. Okay, otherwise the value is your 54,600 liters per minute when the population is your more than 2 lakhs. Okay, this is about your for a centrally high valued city, okay, for a congested city. Now if it is a residential city, okay, if it is a residential city, then also these some values are given for the rate of fire demand according to the size of the buildings. Okay, according to the size of the buildings, the rate of fire demand is given. Suppose it is a small building, okay, it is a suppose a very small building or a very small house, then the water requirement is your 2,200 liters per minute. Suppose it is a higher building or it is a larger building than this small building, so it will be your 4,500 liters per minute. Suppose if it is a apartment or if it is a like 3 4 stories or 5 stories, sorry, first or second stories are there, so or it is an apartment, then you can be using your 7,650 to 13,500 liters per minute. And if it is a 3-story building and if many people are residing there, so you can use up to your 27,000 liters per minute. So these values are already been measured and these are recommended by your National Board of Fire under writer's formula. Okay, so these values are already been suggested. So now next one is your Buston's formula. The last one is your Buston's formula, which is stating that Q is equal to 5663 root over P. So it is again P and Q are having the same meanings, like it is Q is your amount of water that is required in liters per minute and P is your population in thousands. Okay, so these values you will be suppose any numerical is given, which we will be doing in the next class, then you can understand so where to use which formula. Okay, in a numerical in which formula you are going to use, you can know that. Okay, so basically, but you have to remember all these formula, because what is a Freeman's formula you have to know, then what is a Kuchling's formula you have to know, which is a Buston's formula you have to know. So these formulas you have to remember. There is no way out. Okay, so next is your, okay, what is the time? Okay. So next, last one is your water that is required to compensate losses in taps and waste. So what does this line mean is that, in a pipe you can see that there sometimes there are some, some holes. Okay, and due to that holes, some leakages are happening, and due to that leakage there is a loss of water. There is loss of water happening, or suppose there is a damaged, there is a meters, or some people are stealing the water from this pipe connections. So all these things are included in your water that is required to compensate losses in the taps and waste. Okay, and these losses, while you are designing the water supply scheme, you also have to take into consideration this water required for these compensate losses. Okay, so this is about your water demands. What are the types of water demands that are existing? So next is your, you have to okay, one thing let me tell before closing the class. So the per capita demand already I have told you. So per capita demand is this term you are going to get in this subject each and every time. So you should be clear what is per capita demand, and this per capita demand, it is your small q. It is denoted by small q. So what is per capita demand? Already I told that. What is the average amount of water? Okay, what is the average amount of water one person, suppose you are using, how much amount of average amount of water you are using in a day. So that is your per capita demand. Whether it may be due to it may be because of domestic use, or it may be due to industrial use, whether it is of public use, anything, but what is the average amount of water one person is using daily, so that is known as your per capita demand. And also it is denoted by small q, and there is one formula for finding out the per capita demand in liters per day per head. Okay, lpd. So that is your total yearly water requirement of the city, that is denoted by capital V divided by 365 into design population. So design population, it will be given to you. So total yearly water requirement, if it is given to you of the city, then you can easily find out what is the per capita demand in liters per day per head. Okay. So this is about your per capita demand. So next, quickly let me, okay, so this will take time. Okay, next things we will be discussing in the next class. Okay, up to here, I hope this is clear to you. These are easy, only water demands and what are the types of water demands and all the formulas required for finding out the rate of fire demand. Okay. Okay, so
Ma'am,
can you,
can I ask
yes,
one question?
yes, sure.
Okay, ma'am. For one person's for no, per head, it is around for domestic use 200 liter.
Two, how, which one? 200.
For domestic
Ah,
use.
yeah.
So I have seen lot of places and all, but it only one house get only around 200 liters only, where
Mm,
there is a lot of populations. So
mm-hmm.
it cannot be as accurate as it is given.
Yeah. Actually, you know what? These things, whatever in books, the values are given when you are, you become an engineer. So when you are going to any site where whatever things you are using in, like for suppose design, or this, it can be for design also. If you see later, you will get to understand. So whatever values are written in the book, these are only, like it is suggested by some is codes or some things like for from a person. But actually if you go on a real site, or you want to if you, then only you can know that actually these values are not that accurate. Okay, these are not that accurate. These can be, this might be, it can, like what is it is said, it can increase also, it can be less also. Okay, but while you are studying, then you have to, these are, since these are suggested, you have to remember these values only. Okay, but while you become an engineer, because I have seen many of my friends, they tell us that whatever values, like for reinforcement, whatever things are given, whatever numbers are given, we are not using that. These all depends upon the experience. Okay, so from the experience they are you doing all these things, but for your study purpose, you have to remember these values. And these are actually, these 200 liters per head per day, these are actually written in the is code. And also these, I guess these are given 200 liters per head per day, it is given in the this for a town or a city, it is given and this is the minimum domestic consumption. It can be increased also. Okay.
Ma'am, what about the lot of constructions
Lot of
using the
constructions.
waters?
Yeah,
No
that will.
constructions of
Hmm,
house, home.
hmm.
Do then
That will be a commercial one. That will be a
commercial?
yeah, that will be that. It will not be in domestic one, because domestic is only you are using the water in your homes, residential for your own purpose, and constructing it will be a commercial.
Okay, that will come under commercial,
Yeah,
like
commercial.
construction of road and
Yes, yes.
house and all.
Yes, and if it is even if you are using in a public in a public place, then it will come under public water demand.
Okay.
Okay. So let me take the attendance.
Ma'am, can you please show me that per capita demand formula again?
Oh, okay, okay, okay. The class will get over in 5 minutes. Okay, let me quickly show you. Okay, this one. You're talking about this
Yes, ma'am.
one. Okay,
Okay, ma'am. Thank you.
okay. I will share this one now. Okay. Okay, so can you quickly, acha, you do one thing, you give your roll numbers in the group, okay? The link will get closed now. So you give your attendances in the group now, okay? Within 10 minutes you give. Okay, after 10:15 or 10:20, I won't be accepting your attendances, okay? So within 10 minutes you give your attendance, and this one I will share to you. Okay, thank you everyone. You may leave the meeting.
Okay, ma'am. Thank you.
Thank you.